Hello students, welcome once again to the series. First of all, I will say sorry to all of you, those who had been following these videos, the questions, the solutions, because I couldn't maintain that continuity because of several many reasons. But not not today. From today onwards, I will definitely try to maintain this continuity. And see, there are going to be board exams also started. Rather in NCRT, CBSE, they already started. In Telangana board, AP board, they are going to start in few days from now. So the frequency of video will a bit slow down because of those things, but we will be continuing with 3 videos at least in a week. That's what I committed, and I will still try to fulfill that commitment. And once the board exams are over, the frequency will be increased to a next level. Okay, we'll be having at least 5-6 videos in a week, bachcho. So let's move to the practice questions for indefinite integral mains level. The sheet I already uploaded few days back. Now let's start with the first question. See, I just try to cover as many different type of questions as I can. Okay, there might be repetition, 1 or 2 here or there, but I tried my best to keep as many different type of questions which I found to be very relevant, or those type of questions which had been asked. See, that's a question which I discussed with my students before JEE mains also, and that was the question, that was the type of question which they asked in one of the shift in the indefinite integral. If I don't, if I could remember it correctly, the question, the factors were different. They would have been different, but I still remember the sum was 26 by 13, the sum of the power here. Okay, the speciality of this form is if you have 2 linear factor in denominator, okay, and then if the sum of their power is 2, then the method is fixed. It's almost mechanical type of thing which we always do. What we do is we try to divide one by the other. Okay, so if I write x plus 3 and divide it by x minus 2, of course, with the power 8 by 7. So what does that mean? That simply means I divided it by x minus 2 raised to the power 8 by 7. So I need to multiply also by x minus 2 raised by 8 by 7, and we already have x minus 2 raised by 6 by 7. Now the beauty of this form lie in the fact that when we will replace this by t, okay, so let me just complete it. So what we have is x minus 2 whole square into x plus 3 over x minus 2 raised to the power 8 by 7. As I said, let us replace. See, that's one type of question which you people should never miss from here onwards. Okay, now assume it to be t here. See, till what like type it will work. What I have seen and checked and verified is that it will work till you have same coefficient of x in both the linear factors, and the sum of the power of linear factors is 2. Till you have that form, this method will work. But how will it work? Now, of course, you will differentiate to replace dx in terms of dt. So what you will have? You will have x minus 2 whole square using our quotient tool, this minus x plus 3 into derivative of x minus 2 is of course 1, and dx is equal to dt. Now look at it. So what do you get in numerator? X gets cancelled, so it's nothing but minus 5 upon x minus 2 whole square dx. And that's what you have in the integral, which is nothing but dt. So just replace it. So I is minus 1 by 5, and this is dt by t raised to the power 8 by 7, and we are done, bachcho, isn't that? So it's nothing but minus 1 by 5 t raised to the power minus 8 by 7 dt, and the integral is minus 1 by 5 t raised to the power minus 1 by 7 over minus 1 by 7 plus c, and then replace t by x minus plus c upon x minus 2. That's it. Okay, then you can check it with one of those options. Yeah, you have 1 by 5 and then 7 by 5, something like that, and then you can match the answer. Okay, the form is important, the methods are important. Okay, and wherever see, I tried it using different methods, or I solved it with some other method, and my students here in the campus here in Hyderabad, Turuto, they solved it with different methods. So definitely I will share both the methods there. Now moving to this form, see, that's one question. That's one question where I will say, see, whenever you have even power of sine and cos in denominator, all the terms all the terms have even power of sine and cos, one method you can always try is divide by the highest degree term of cos raised to the power. Okay, so whatever, so highest degree term here is cos raised to power 4, so divide both numerator and denominator by that, so you get it in the form of tan here. So it's 1 plus tan raised to the power 4x, isn't that? Now of course we know we will be replacing tan x by t, so in that case when you differentiate sec square x dx by dt here, so what do we get? So this is sec square, so one sec square goes with dx to give us dt, so the other one is sec square left, we will be replacing it with 1 plus tan square, which is 1 plus t square, and this is 1 plus t raised to power 4, again a very important and a standard form. And how do we approach it? Now what's the standard form? If you have biquadratic with even degree terms only, if you have biquadratic in denominator with even degree terms only, and you have a quadratic in numerator again with even degree terms only, then what do? You divide both numerator and denominator by t square and you get it in this form, and whatever you have in denominator try to express it in the form such that its derivative is sitting in the numerator. So of course for t square plus 1 by t square we have two choices. We can write it as t plus 1 by t whole square minus 2 and t minus 1 by t whole square plus 2, isn't that? So just replace it here. So what do we get? So this is nothing but, so of course whose derivative is in the numerator, so we'll be writing in this term, so we'll be replacing the denominator in that term, so it's 1 plus 1 by t square dt over t minus 1 by t whole square plus 2 and let, and then you know how to do it, isn't that, z, and then this is nothing but dz by 2 plus z square, isn't that, and its integral is tan inverse of z by root 2. Okay, we already know how to integrate dx by a square plus x square. I believe all of you must be knowing this formula. Okay, so apply it, you get the result. So that's it. One more choice here was that, see, whenever you have a raised to power 4 plus b raised to power 4, you can directly write it as perfect in terms of perfect square. So you may prefer to write, or you may move ahead in using this form also, sine square x plus cos square x minus 2 sine square x into cos square x. Okay, now this is nothing but dx upon 1 minus, and then you can write it as sine square 2x by 2 bachcho. This is what again you can try here. Okay, now see, again you can convert it to tan, that's one thing, writing it as 2 tan x upon 1 minus sine square whole square, whatever, or then you can divide again by cos square, because you have a combination of even power of sine or cos in the denominator. So again the method will be the almost the similar on the similar pattern, bachcho. Okay, so then again either again I am repeating, so you will take LCM, of course you will take LCM, there will be 2, there 2 and 2 is gone, and then again either divide by cos square 2x in both numerator and denominator, or you can again convert sine 2x in terms of, right, sine 2x in terms of tan, and then you get back to the same form. Okay, so that's it. Now moving to the third question. Now see, third question though is a very simple thing, but again why did I choose it? Because see, normally what students, the mistake which students commit here is, so if that's the situation here, okay, so it's a direct, see, whenever you have 2 or more than 2 factors in the denominator, you have a choice of using partial fraction as a method. Okay, so for me it's a direct question of partial fraction. The only thing is that I won't be replacing x square. See, if you go ahead blindly using partial fraction without simplifying to any step, or without simplifying it to the next level, it is going to be very lengthy, because you have quadratic factors in the denominator, and we know while using partial fraction, if you have quadratic factor in denominator, for every quadratic factor you have to introduce a general linear factor in the numerator. Okay, so you will having so many unknowns there, at least 4 unknowns will be there. But what will I suggest is, I will say, okay, out of the integral let x square be t, so this implies it's t plus 2, not within integral, minded bachcho, t plus 1 into t plus 4, so I will write it as a upon t plus 1 plus b over t plus 4, isn't that? Now when you take LCM, so I will solve it a bit. So when you take LCM and then cancel out the denominator both the sides, So a times 3 plus 4 plus b times 3 plus 1. Now see, the method which I prefer is that I always tell to my students that for every linear factor, now you have two linear factors in the denominator and you have just two unknown a and b. So for every linear factor, find its root and put it in this identity statement. Remember, this is an identity statement which is true for every value of t. Okay. So what we do? So put t is equal to minus 1 here. So you get 1 here, and then this is 0 and 3a. See, you got a, which is 1 by 3 here. Similarly, put t plus 4, another linear factor, as t is equal to minus 4 here. And what do you get? Minus 2 is equal to a gone, minus 3b. And b is nothing but 2 by 3, and you have then, then what? So then you say, therefore, integral is, see, of course, we are able to partially write it in the, like, factorize it or partial fraction form. We are able to write it. Okay, now replace t by x square. Okay, so that means integral is nothing but x square. So it's a is 1 by 3. So 1 by 3 times x square plus 1, and b is 2 by 3 times x square plus 4. So both are your tan inverse direct result, and then you can easily solve it. Okay, the normal mistake here is that at times what the student do is they replace x square by t within the integral. See, if you are doing it within the integral, then you need to replace dx also in terms of dt, and once you try to do it, you get root t. You get root t in the denominator, and then there's a problem with you. Okay, so that's one thing. Another method is you can just simply try to like balance it, long division method type of thing. So you can write it as x square plus 4 upon x square plus 1 into x square plus 4. See, that will lead to the same situation with you. Okay, that will lead us to the same situation. So adding 2 minus 2, so minus 2, and this is dx upon x square plus 1 into x square plus 4. Okay, now that's one case, and then what you do, you again, so it's minus 2, so you can you write it as x square plus x square. Okay, so the 1 plus 1, so you can write it as x square plus 1 minus x square plus 4, something like this. Okay, and then you can go on like reducing it. So that's another method which we take it as long division method type of thing. So you have partial fraction, which is set method for such type of question. That's one method which one of my students solved it or used it by solving this question. So that's why that's what I said, wherever I have some alternate method, I will be discussing it with you people. Now that's another question, now interesting one. Okay, so for that, of course, what would have been the first step you would have tried? I think that's what you all would have done here as the first step. Now see, in such type of question, the first thing, see, method of substitution is the most important method of integration in indefinite integration, bachcho. Okay, so that's one thing we always need to keep in our mind, that can we convert our one part of the integrand as in the form such as its derivative is lie in the second part of the integrand. Okay, so what I tried here was take x is power 4 common here. So you get x is power 13, isn't that? So 1 plus 1 by x is power 4 raised to the power 1 by 2. Now of course, what's the choice? We don't have any choice. We will be replacing this by t. So minus 4 by x is power 5. Dx is dt. Okay, so dx by x is power 5. Now this is x is power 13, so I can write it as x is power 8 and remove it into x is power 5. So dx by x is power 5, I will be replacing it with by minus 1 by 4 dt. But what about x, 1 upon x is power 8? Okay, so from here you can say 1 by x is power 4 is t minus 1. So therefore 1 by x is power 8 is t minus 1 whole square, and this is nothing but root t. That's it. Okay, now what? See, now you can go for t is equal to z square, let's say. So then it's dt is equal to 2z dz. So therefore our integral is, now some of you can definitely say that we could have simply assumed this as t square, of course, but then see, most of the times I will be solving questions. See, I would have solved this question quite back, okay, maybe. So most of the times I will be solving it in front of you. So the way that things strike my mind, I am solving it for you, okay. So just after looking at the expression at this point, I realized that I can replace it with z square. So what do we get? So we have it as minus 1 by 4 and then dt is 2z dz, so 2z dz upon, and this is t minus 1, t is z square minus 1 whole square, and then it is z and z is gone. Okay, now you can easily do it. So minus 1 by 4, and as we already know what you can, so it's minus 1 by 2 here bacho, so minus half here, and then see, as I said just now, it's the biquadratic, perfect biquadratic here. Is that? Why shall I write it in this form when we already have as a perfect square? I will like to take z common here, so we will have z square here, so z minus 1 by z, and that's it. Okay, so 1 by z square will go to the numerator, so it's minus half, and minus half, and then it is 1 by z square. Now see, its derivative is 1 plus 1 by z square, so add 1 and then subtract 1. For that I will say that multiply and divide by 2 here. Okay, so 1 plus 1 by z square and then plus 1 by z square minus 1. I think all of you got the idea bachcho. So it's z minus 1 by z whole square bachcho, theek hai. What I did, I just see it's 1 by z square, so I made it as 2 by z square. So there are two 1 by z square term. So once I added 1 to it, and then of course to balance it I wrote it as minus 1, so it's completely balanced. Okay, now I will break it into two integrals here, minus 1 by 4 times, and see its derivative. So its derivative is this one, so this one is sorted, I think bacho, z minus 1 by z whole square. Okay, now for the second one you have minus 1 by 4, so if I take it as plus common, minus common, 1 by 4, 1 minus 1 by z square, but to have this as a derivative we need to have z plus 1 by z. Okay, so I will write it as z plus 1 by z whole square minus 4. I think it's balanced. Okay, z minus 1 by z whole square is z plus 1 by z whole square minus 4, that's it. So you replace z plus 1 by z by p, so it's dp by p square minus 4, and this is simply dp by p square, that's it. Okay, so that's your next question. Now moving to the next one. Now see this one is a direct question of partial fraction. Again, why did I take it? Because see, first of all we need to observe, if you have a polynomial in denominator, the first thing I try basically is I try to factorize it. Okay, because if we get linear factors, then one thing is for sure, there might be other methods also, but one thing is for sure that we can definitely apply the partial fraction method. So that simply ensures that the question will get solved easily. Okay, now let's try it. So see here, the degree of numerator is more than degree of denominator, and we know that when can we apply partial fraction? We can apply partial fraction only when degree of numerator is less than degree of denominator. So this thing I always say, dividend by divisor is equal to quotient plus remainder by divisor, and we know that the degree of remainder will always be less than the degree of divisor. So this is dividend, this is divisor. So using long division method, so if we divide it by the divisor, which is x cube minus x square minus 2x. Okay, if we divide it by divisor, so x makes it as x is power 4. So what am I doing? X is power 4 minus x cube, and then minus 2x square, and then subtracted. So this is it. So it's x cube and then minus x square minus 3x minus 2. So again it will be just plus 1 here. So x cube minus x square minus 2x, and that's it. So minus plus gone, and that's minus x minus 2, done. So the quotient is x plus 1, and the remainder is minus x minus 2, I believe. Yeah, so minus common x plus 2 upon the divisor, which is x cube minus x square minus 2x. That's it, bachcho. Okay, now see, Now we have to integrate it. So when you have to integrate it, what are you going to do? So its integral is simply its integral plus its integral. So this integral and integral of this thing. So that's of course we are done with it. X plus 1 integral. Now for the second one, as I said, the first thing which I observe is, can we factorize it? Okay, yes we can. That's what I said. I have already observed that x square minus x minus 2. So it's x minus 2 into x plus 1. So we have three linear factors in denominator. So you write it as a upon x plus b upon x minus 2 plus c upon x plus 1. And then we know how to do it. We have already seen one such question earlier. Okay, fine. So now moving quickly to question number 6 here. Question number 6, see, the purpose of taking up this question is that we already know in our that segment, the by part, integration by part segment, there is a result e raised power x times fx plus f dash of x. So its integral is e raised power x into f of x plus c. We all remember it. If not, then now remember it and don't forget this. Okay. But here the problem is, it's not e raised power x. It's 3 raised to the power x. Okay. Then I realized that it's the general form. See from here. Achha, let me do it. Okay, let me do it for you people. So I will take it as into g of x. This is, see, the point is, how do we get this result from by parts? Okay, so let me do it quickly here. So plus, so I will be writing it as two different integral. I think all of you will agree with that thing. Okay, so that these are two different integral. Now applying here integration by parts using the rule of IIT, and we don't need IIT actually because we don't know anything about gx function. So of course we are not going to integrate it. Okay, so this is going to be our first function because we don't know about it, and this is of course the exponential function is the second function. So using IIT in the first integral, what do we get? So I is equal to ln 3 times. Okay, first function g of x into integral of second function, which is 3 raised to the power x upon ln 3 minus first function derivative g dash x into integral of second function 3 raised to the power x by ln 3 whole within this integral. So that's it. And then you have the second term, which is 3 raised to the power x into g dash x dx. Okay, now look at it carefully. Okay, if I take ln 3 inside, this gets cancelled. Now this gone, so it's simply like 3 raised to the power x into g of x, of course, plus c. So in general, if we wish to generalize it, so what's the general form? The general form is g of x into ln a plus g dash x. This integral will be a raised to the power x into g of x. Okay, so that's how very easily we can generalize it. So the purpose of this question was to discuss this part only. Okay, so that's it. Now moving to the next one. The next one is again the question of by parts. Okay, sin x, see, there are product of two functions, and when you differentiate ln of cot x by 2, there's a chance that we will get it in terms of sin and cos. Okay, so let's apply. So of course here again log term is there, it has to be the first function. So if I write it directly, so first function ln cot x by 2 into integral of sin x is how much? Minus cos x, isn't that bachcho? And then minus derivative of ln cot. So derivative of ln is cot x by 2, and then derivative of cot is minus cosec square x by 2 into half, and then integral of sine, the second function is minus. Okay, so that minus makes it plus within integral dx. Okay, so I think settled. So I can write cot as cos upon sine. Okay, so this I write it as cos x by 2. One sine goes to the numerator, cancel it out with cosec. I will bring this cosec in the denominator, so it's cos x upon 2 sin x by 2 into cos x by 2, and we got it bachon. Okay, so it's minus cos x upon sin x, so it's nothing but cot x, so its integral is ln sin x. So that's it. So the answer is minus cos x into ln of cot x by 2, and then it is minus ln of mod sin x plus c. That's it. Okay, so you can match with any one of these form, and then you can do it. Okay, now see, if you wish, you can see which form does it match. Minus cos x into ln of cot x by 2. That's the only form which it matches. So then you can, yeah, see, it's the same thing, isn't that? You like sec x by 2 as 1 by cos, so it will be minus, and here minus cos x by 2. Okay, then you can combine it. So minus times ln sec x, sin x by 2 into cos x by 2, multiply by 2, divide by 2. ln 2 is a constant that you can merge with c, you will get the same answer. So that's it. So A option is the correct answer here, bachcho. So now moving to the next question. See, next question is that's what I said, because I realized when my students here were solving these questions, that is the same question. I mean, it's a very similar question. Okay, so denominator is a simple quadratic which can be very easily factorized, and in numerator the degree of numerator is greater than degree of denominator. So again you will be writing it as integral of quotient plus integral of remainder upon divisor, which is x minus 2 into x minus 3 dx, and that's it. So we have already done it. I am not going to go into its detail. Now next is this one. See, the first thing we tried while solving here was, see, you people see, there's in indefinite integral, as I always say, that there's nothing called wrong or correct in this here. Like sometimes students say, so what's the wrong in this matter? I didn't get the answer. Okay, or what's wrong in whenever I proceed like this, but we are not able to integrate. There's nothing called right or wrong here. Okay, the only thing which matters here is the form which can be integrable, one thing, or is the form with which you can get the integration in the form in which it is given in the options. Okay, normally the options, if you get some different form in the as the answer and the options are in different form, normally we can interchange it. That's one thing. But then moving like using different steps or moving in different directions, and then if you get stuck and can't integrate, doesn't mean that the method was wrong. The simple thing is that the form which you got may not be integrable in our term, in our course. I mean, with the limited methods which we have, we might not be able to integrate it. Maybe down the line, when you go into the detail of integration, you might be knowing several, in higher mathematics, several many other methods with the help of which you may later integrate it. Okay, so that's different thing. So I never say something is correct or incorrect while you are solving this like in any indefinite integration question. Okay, so the only thing matters is whether the form which we get is integrable. I mean, integrable in the term, in the sense that with the limited methods we know, can we use those methods to integrate it or not? That's the simple thing. Okay, now see, as I said, the first thing which struck my mind while looking at it was writing cos 4x in the form, so that 1 gets cancelled. So we'll be writing it as like 2 cos square 2x minus 1 plus 1, isn't that? And then of course cot x and tan x in terms of sine and cos, so it's cos square x minus sine square x, and then upon cos x sine x, isn't that, bachcho? And that's what we'll get. So this is gone. So you have 2 cos square 2x, so you get 2 cos square 2x into sin x cos x upon, what is it, cos 2x. So see, it's a simple one, and then it is sin 2x, so it's half sin 4x. A very simple one. So that's the one of the simplest one, isn't that? But the only thing is, once we get the form, then it seems to be simple, isn't that? Now moving to this one, see, again here, what I will suggest is P plus Q is 12. See, again, P plus Q is 12. Okay, so if we write it in terms of sine and cos, so sine x raised to the power, see, of course, if I talk about myself, I am far more comfortable in terms of sine and cos than in terms of cosec and sec, bachcho. Okay, that might be the case with several of you also. Okay, now I will convert it to tan. So why? Because see, sum of the power p by 3 plus q by 3 is 4. The power sum is even. Okay, because p plus q is 12. So I will convert it to tan in denominator. So sin x upon cos x raised to the power p by 3. And then you divide it by cos x raised to the power p by 3. We need to add, we need to multiply with cos x raised to the power p by 3. And what will happen? So as a consequence, the power of cos x will add up, which will be p by 3 plus q by 3, which is nothing but 12 here, or rather 4 here. P by 3 plus q by 3 is 4. Okay, so this is sec raised to the power 4x dx upon tan x raised to the power p by 3. Am I done? Tan x is t. Okay, so then if tan x is t, so it is 1 plus t square dt, because 1 sec square will be left in the numerator, 1 sec square will merge with dx to give us dt, and then it is t raised to the power p by t. So you can easily write it as in the simple algebraic terms in the term form of power of t vector. That's it. So integrate it and then replace t by tan x. So we get the answer. Moving to the 11th question. Now that's again a very interesting question. See, such type of question are in existence since years and years, okay, but they had been asked in the JEE mains a few years back only, okay. So that's again a very important type of question where we apply bypass, okay. See, in our assignment, the advanced level assignment, you will find few more better good questions on bypass, okay. Really very interesting questions, very important one, bachcho. So I wish and I hope that people are solving the questions, whichever questions I am posting here as exercise, as a worksheet or practice sheet. You people must be solving it, okay. Now I'll be breaking it into two integrals, and that is 2005 over cos raised to the power 2005 this thing, okay. Now, of course, what's the choice we have? As I said, it's a good question of bypass. Now, apply. You don't have a choice. You'll be applying bypass here. And of course, the integral. See, how do we select the first function and the second function? The reason behind the list, that term ilative, where we the choice of first and second, we decide on the basis of which alphabet lie above the other. The reason behind it is the function which is easily integrable. Our first choice is that to be, that has to be the second function, because when we apply the formula of bypass is the second function only which gets integrated directly, okay. And looking at here, we know that the integral of cosec square x is direct, which is minus cot x, okay. So for sure this is going to be our second function, and this is the entire 1 upon cos is our first function, okay. So let's apply. So it's 1 upon cos 2005x into minus cot x, isn't that? Minus integral is again minus cot x, so I integrated it first, and then its derivative will be minus, using chain rule, minus 2005 cos 2006x into minus sin x dx, okay. So there are plus here. Now I will write cot in terms of cos and sine. So our integral is minus cot x by cos raised to the power 2005x plus, okay. So it's cos x by sin x into 2005 sin x by cos raised to the power 2006x dx. Now look at here, 5. Now, doesn't that gets cancelled with this one? So that gets cancelled, and that's the answer, plus 3. That's it. So it's really a good question. Okay, so I really like this question. Okay, so that's why I decided to share it with you people. So moving to the question number 12. So now again, very good question. See, one thing while solving this, because you may ask me, or that question again can strike your mind, that how could I think, or how can anyone think that what I have to do? See, of course, I always say when you have e raised to the power x as a product, and within the bracket you have two different functions, okay. So normally we try to match it with fx plus f dash x. Now to be true, I really tried very hard to compare it with fx and f dash x. I tried, but I couldn't get it. You may also try, you may get it. I'm not saying you won't get it. But then what I realized was, see, I observed this thing for some time, then I realized, see, if I differentiate 1 by under root of 1 plus x square once, so whatever you get in the numerator doesn't matter. I mean, of course that matters, but when I was analyzing it, I realized it will be under root of 1 plus x square or power is 3 by 2, and once again when I differentiate it, it will give me the power 1 plus x square raised to the power 5 by 2, and that's what I have in the second term. So there I decided, see, that's the first time, to be very true, first time in my teaching professional life, I think I've been teaching since last 22 years, if I'm not wrong. Yeah, 2002 to 2000, no, almost 23 years. I started in May 2002. Okay, so we are in March, Feb 2025. So almost 23 years. For the first time, I used this thing. Okay, what was that? I applied by parts in this because I know, we all know rather, that how do we get this form? E raised power x into fx plus f dash x, that is equal to e raised power x into fx, applying by parts in one of the term and then getting the second term as cancelled. Okay, that's what I tried. So I just used by parts in this one, the first one. So which is e raised power x upon under root of 1 plus x square, keeping intact the second one, keeping intact the second one. Okay, and then as I already knew that I have to apply at least twice to get the denominator there, and then I was just wishing to God, okay, or relying on my good luck that I get the numerator also. Now let's see. So applying by parts, of course this has to be the first function, so 1 upon under root of 1 plus x square, e raised power x minus e raised power x, its derivative is minus half under root of 1 plus x square, and then cube, okay, into 2x. So this is gone. So plus e raised to the power x upon 1 plus x square raised to the power 3 by 2. Okay, now again applying by part, that's what I said. So plus, so x upon 1 plus x square raised to the power 3 by 2 e raised power x minus, okay, e raised power x integral and then its derivative. So its derivative is 1 plus x square raised to the power 3 by 2 using a product rule, quotient rule here. So it's 1 plus x square raised to the power 3 by 2, rather it will be whole square, so it's cube, and then into derivative of numerator, which is 1 minus x into its derivative of denominator, it will be 3 by 2 into 1 plus x square raised to the power half into 2x, isn't that bacho? So 2 will get cancelled, and then under root of 1 plus x square will be common from here. So let's take it out. So therefore our integral is, so how much is it? So just a minute. So we have first term e raised power x upon under root of 1 plus x square, right? And then we have the second term plus x times e raised power x upon 1 plus x square raised to the power 3 by 2, and then we have third term within integral, which is minus e raised to the power x upon, as I said, take, that's what is clearly visible, under root of 1 plus x square from the numerator common, and then it gets cancelled. See, we got 1 plus x square, that was the primary target here. Okay, now what are we left with? So we are left with 1 plus x square there, first term. So 1 plus x square minus 3x square, and I think we got it. So minus e raised to the power x into 1 minus 2x square upon 1 plus x square raised to the power 5 by 2 dx. Now let's match it with the second term. It's plus 1 minus 2x square. So this term and this term gets cancelled. So that's the answer, of course, with plus. See, that's it. Okay, so that was really very interesting. Okay, so that's it. So if we know from where we get that form, we can apply it. So by parts comes to be very handy in that case. Now that's a very simple direct question. X square, its derivative is 1 minus plus 1 by x square dx. So simply differentiate it, nothing more. So take x square common from denominator, and that's it. So that's gone, and then you can write it as x minus, we have already done this, isn't that? And that's it. So its derivative is sitting in the numerator, so dz by 2 plus z square, and then you can match the answer. So that's it, question number 13. Moving to question number 14 here, the value of this integral. Okay, say here again, the first thing which we will try is, again, see, what I tried was convert it into sine and cos here. Okay, so I wrote sine 2x as 2 sine x cos x plus 2 sine x by cos x, then that. And then in denominator we already have everything in terms of cos, so no need to further simplify it. Okay, so see, initially this question took some time for me to get it to the form which I thought to be useful. So cos square x, or the form in which I thought I can easily integrate it. Okay, so then I took cos inside, cos 7 plus 6 cos cube plus 4 cos x. And of course we have seen this step is very clearly evident, visible. What we have to do? We will replace cos x by t, and so as to get it as, so therefore integral is minus 2 1 plus t square dt upon t raised to the power 7 plus 6t cube, if I am not wrong, yeah, plus 4t. Now here's the thing. Okay, so see again, that, though it's a very standard thing, normally that's what I do in such type of question, taking the highest degree common from denominator and then wishing that whatever remains in the denominator is derivative we get in the numerator. That's what normally I do, but here I just got stuck because that thing didn't strike, so it took some time for me to again go to it. So then taking t raised power 7 common here, so t raised power 7 is this, so 1 plus 6 upon t raised power 4 plus 4 upon t raised power 6, and then 1 plus t square. Now take t raised power 7 to the numerator, so minus 2, so it's 1 by t raised power 5 plus 1 by t raised power 7 dt. I think, bachcho, now you people can see easily what are we going to do. So of course, so next is 1 plus 6 upon t raised power 4 plus 4 upon t raised power 6 may be z. So if you differentiate it, what do we get? We get minus 24 by t raised power 5 minus 24 by t raised power 7 dt as dz. So take minus 24 common, and then we have whatever we have, exactly the same expression we have in the numerator. That's it. So the integral is simply and direct, and that is minus 24 will be, so 1 by 12, and this is dz by z, if I am not wrong. Yeah, it's dz by z, so ln of z. That's it. Okay, so that was again a good question, I will say. Now see, again, discussing this question, see what we have to do is we have to just see odd power of tan. If we have odd power of tan, what can we try? So I will write it as tan cube x into tan square x, just to discuss with this standard matter. So whenever you have odd power of tan or cot, this is how we approach bachcho. Okay, and then tan cube into tan square x secant square x minus 1 dx. Okay, now of course we can break it into two integrals. So one is tan cube x into sec square x dx, and minus tan cube x, which again I will write it as tan x into tan square x dx bachcho. Okay, now see, if I replace tan x by t here, okay, so this is sec square x dx is dt, so it's t raised power 4 by 4, isn't that minus? So as I said again, so the same thing into sec square x minus 1 dx, so it's t raised power 4, which is tan x raised to the power 4 by 4 minus tan x into sec square x, again tan x as t, so it's t square by 2, isn't that? And then minus integral of tan x. So integral of tan x we all know is ln of mod sec x. Okay, so it's tan x raised to the power 4 by 4 minus tan x whole square by 2 minus ln of mod of sec x plus c. So I think those should be the type, yeah, 4, 2 and ln of mod of sec x. That's it. Okay, so then you can match it. So moving to second last question. Second last question is this form here. See, we have two forms. Okay, one form is, again, if you can match it with this one, and this is e raised power gx into fx f dash x plus fx into g dash x. You get it in this form, then answer is direct. Okay, but see, I wrote it for you people. You can try it and we will get it. Okay, sine square x is our gx, so we bring sine inside and then you can get it. But see, for me it was much simpler a question, because if I replace sine square x by t, that's the first thing I always try. Okay, then its derivative is 2 sin x cos x, take cos x common. Okay, so it's sin x cos x dx is dt by 2. So therefore integral is e raised to the power t half. Take cos x common, cos x sin x dx is dt, so it's 1 plus t square, 1 plus cos square x. Cos square x can be written as 1 minus sin square x, which is t square, and that's it. Okay, so now you can easily apply. So this is 1, 2 gone, and this is half times e raised power t into t square dt, and then apply it by parts. Simple. That's how I did. You can try to convert it to this form and then match with this form. You have the answer directly, bachcho. So that's it. So moving to the and the answer is also in that form only. E raised power sin square x, e raised power gx into fx. You have to just find the fx here. I think these two are the answers if I am not wrong. Here it's it's sin square x. Now A and B both are the correct options. Okay. So moving to the last question here, again a very important, very interesting question. If you have already done it, then it's really good. If not, then see, try to understand. So if you have somewhere, anywhere, such type of expression within a square root, you have a different looking expression, and then see what's the option we have. The only option I think we have is method of substitution, but then which function should be our t and which one is its derivative? There's no such function. See, what we do is we take something common from here, preferably x, only one term x in the first step. Okay, so you're left with x raised power 5 plus x raised power 3 plus x. Okay, and take that x inside. So x will go inside the square root as x square. So it will be 2 times x raised power 6 plus 3 times x raised power 4 plus 6x square half, power half dx. Now let this thing 2x raised power 6, 3 times x raised power 4 plus 6 times x square be t. Differentiate. So 12 common, x raised power 5 plus x raised power 3 plus x dx is dt. That's it. So that's your term here, dx. Okay, so therefore integral is 1 by 12 root t dt, and then you have your answer. Okay, so that was again a very interesting form, bachcho, and though of course very important and very common. Okay, and not common in the term that you will find so many such questions, but you will definitely find one such question in every good book, practice book, or in the package of every reputed coaching centers. Okay, so that's really an important one. So that's it for today. So we are done with our indefinite integration mains part. So now I will be uploading the practice sheet of indefinite integral advanced level practice sheet. Moving to the definite integration, we will be finishing the integral calculus part first, then we will move to the vector algebra 3D probability, bachcho. Okay, so that's the planning here. So after probability, then we will decide. Most probably after probability, I will come back to the conic section, completing parabola, ellipse and hyperbola. That's how I have planned for you people. So chaliye, let's stay connected, stay practicing, and let's hope for the best result we get from you people, bachcho. That's it.